In this video, we are going to look into LeetCode isomorphic strings. Given two strings S and T, determine if they are isomorphic. Two strings S and T are isomorphic if the characters in S can be replaced to get T. All occurrence of a character must be replaced with another character while preserving the order of characters. No two characters may map to the same character, but a character may map to itself. The idea is this one. If you replace E with A and G with D, you will get ADD, which means it's isomorphic character, because you can come up with some mapping like here I will write for EGG. If you want to get this one ADD, you can come up with a mapping E to A and G to D. Using the this mapping, you will get add from egg. Okay, the same way you can check this one, a foo bar. In the case of foo bar, foo, we want to get a bar. F should be replaced with B, and O should be replaced with A, but this O should replace with the A here, so this is not isomorphic. No, it is not isomorphic. So next let us check this one, paper with the title, whether it's isomorphic or not. The same way, let us map P to P will be replaced with the T. A will be replaced with I. Now P is coming again. You can see that T is the mapping is still valid. Next E is coming, so we will put E to L and R to E. Yeah, now we are getting a valid mapping here. Using this mapping, you can convert a paper to title. So this is isomorphic. This is not isomorphic because O is replaced with A first. The subsequent O does not correspond to R. Sorry, A. That's the reason it's not isomorphic. So this is the idea. We need to come up. We need to check whether we can come up with a mapping like this or not. So let me write the code in Java. First we need to define a mapping to keep track of that one mapping. In the mapping we want to characters. We are mapping characters, one character to another character. Okay, so here mapped new hash map. Yeah, we created a mapping. Now what we need to do is that one we need to go through. Okay, let us do one thing before that. Let us find out the length. Int length equal to s dot length of the string. So you can do one thing. You can do one validation check here. If length is not equal to t dot length, which means it's not isomorphic, because if you want to replace one by one character, both should be same length. It's a false. Just a validation test there. Now you need to go through each character. Define I is equal to 0, I less than length, I plus plus. Now we need to get the both character. First character s character equal to s dot character at I The same way I will take first character of the T also. So here I will. So now we go to both the character. Next thing what we need to do is that we need to check whether this character is available in the mapping. First we need to check that one. If mapped dot contain sh, if it is not contain, you need to add. Not contain, then you should add that one. Mapped dot put sh corresponding t character is tsh. For example, I will bring that. What was that example? This is egg and aid is a good example. Egg add E to A and G to D. Okay, so first in the first iteration I is 0 and we will get E, and we will check our mapping contain E or not. In the first iteration it won't be available there. Assume that one. Here is the mapping. This is the mapping, it's empty first. We will check whether mapping contains that E character or not. It will return false, then it will enter here and it will insert this one. So this will come inside here. Mapping is happened. Now next what you need to do is that we need to get the character. We need to check if mapped dot get sch is not equal to tch, then return false. Return false. Basically what I have done is that in the initially we added E to A, then come here and we'll get SCH. Obviously we added here TCH, so it this condition will be false. Next it will check whether G is in mapping or not. It is not there, then it will again add G to D into the mapping. It will add. Okay, here also this condition will be false, and it will go to next condition G. Then here mapping contains will true, and so this entire condition will be false. So it will come here and it will get the SCH. Here SCH is G, then it will get G, it will get D, and corresponding TCH is D. So this entire condition will be false. So like this will happen, and at the end you can add true. If nothing false happened, then it is true. Okay. Okay. Let me once again verify. Map hash map, it is written, and going through each character and taking each character. If it is not there, add, and otherwise false. Okay. Let me run the code. Okay, I forgot a semicolon here. Let me add that. Cannot find symbol t dot length. T dot length. Okay, it should be length. Length. Okay. cannot find symbol contains. Mapped. Oh, contain key. Contains key. Contain key or contains key. There is no suggestion, so I'm not sure. Contains key or contain key. I think it's a contains key. Cannot find the TCH. Okay. Okay, it's accepted. Let's try submit. Wrong answer. BDC. This is the input. Our output is BABA, and expected is output should we say that it's isomorphic, but S is a BIDC and T is a BBB. Okay, let us try. We said it is isomorphic, but actually it is not isomorphic. Let us try like this here. Let us identify what is the issue with our code. So basically what we'll do is that we will take B and we'll add B to B. Okay, that's fine. Then A to A, that also fine. Now D is coming. D to B, D to B. Actually we already used to B already used to for B, so you cannot use again B here. Okay, that's what they are saying, right? Our occurrence of a character must be replaced with another character while preserving the order of characters. No two characters may map to the same character. No two all occurrence of a character must be replaced with another character while preserving the order of character. No two characters may map to the same character, but a character may map to itself. Okay, this is possible. A to A is possible, but here B is mapped to D and B. That is the problem. Okay, we need to solve that problem. So basically here what we need to do is that one mapped, we checked this one. We need to check okay, here the problem is that one we are adding this B key again to map to the new key D, because B is already used for B here. So basically when you are adding here, before that you need to check. So here you need to check if mapped dot contain value, if it is already added as a value, which means it's not isomorphic, so you need to return false here. Okay, let me check this code. Contain value, contains value. Okay, test is fine. Now let me submit and check it is working or not. Yeah, it's working. So yeah, code is correct. Let me revise again. First we checked whether both S and T are same. If it is not same, those strings are not isomorphics. Then what we have done is that we check each character from S and T, and whether checking the mapping already done. If it's mapping already done, we will check that mapped character and character in the T is same. If it is not same, it is not isomorphic. If the character is not already mapped, we will check whether character in the T is already mapped or not. If it's already mapped, means you can't map again, so it's not isomorphic. Then map it. Okay, the code is working, code is fine. Let us check the time complexity. You can see here we used one loop here, so it will go through length of the string, which means on. Here time complexity on, and here you can see we used one more contains value. So this also will contain on because it is checking the value, not a key. Can we make it as a faster replacing this code? Anything else? So what we can do is that one to make it faster there. It is time complexity. Yeah, means it is on square. In worst case, it can be on square. So I will introduce you one more data structure here. That's a set. I will store all those characters in this set. What should be the type character, and used char new hash set. Basically I will store there if it is used char contains this one, then it is false. Otherwise used char dot add tch, basically tch. Okay, basically what we will do is that one every time if we mapping a character for the source character, destination character, S is the source character and T is the destination character, which means S will be replaced with a T. The replaced which character we are used for replacing, that character will be stored in the used char set. Basically that is the value of the mapped hash map, because checking in the value it will on a linear time needed. So to avoid that one, we will we introduce a set and we will store the value inside that. The values value of this mapped data structure we will store in the set, and we will check whether it's already contained or not. If it is contained, means it is used for some other character, so we should return false. We'll check. Okay, it is success. Okay, I will explain once again. First we will check whether both the strings are same length. If it is not same, obviously that is not isomorphic. Then we introduce it to data structure. One is a map. Here we will map a character and the character for replacing. Source character is a destination character. Yeah, whatever it is. And then we want to check whether one character order is used for mapping. We want to check it in a constant time. So for that purpose, we use set data structure. Otherwise, you can use you can check from the mapped the dot contains value whether the value is used or not. But their timing is linear. For that purpose, we used a new data structure set. Here contains check is only constant time. Then we will go through each character and we will pick the source character and destination character. and we will check whether it's already mapped or not. If it is S is already mapped or not. If it is not mapped, we will check whether the destination character is already used or not. If it is already used, means it is not isomorphic. Otherwise, we will add values in the used char set, and we will add the mapping also. After that, we will check whether SH is mapped to TCH or not. If it is not mapped, it is false. All the iteration is over, then you can say it's isomorphic. That's all. Thanks for watching.